Hey guys, hope you remember that I told you that there is a shortcut to doing those long ground state configurations for electrons, and those are noble gas configurations. So that's what we're going to look at today. The noble gases are over here. They are group 18 on the periodic table, so at the end of the rows. So let's take a look at the first one and learn how to do these. Let's look at a couple of examples together to get you used to doing these before you go. Hello guys! Today we're going to do another type of electron configuration called orbital diagrams. Get ready to take good notes because we're going to have a quiz at the end of this and it's going to count towards your grades, so make sure you're writing everything down. You can pause when you need to. Alright, so let's talk about how orbital diagrams work. Each sublevel, S, P, D, and F, contains things that are called orbitals. Now, don't think of orbitals as your picture of the atom in your head with, oh, what's going on here? With these around it, okay? That's not what we're talking about when we're talking about orbitals. These can be some confusing vocabulary, so you got to pay attention. Orbitals are electron clouds that hold the electrons 90% of the time, so they're different than that. This is so important, and I will ask you this question on tests and quizzes. I will ask you how many electrons can fit in an f orbital, and you're going to tell me 2. I'll say how many can fit in an s orbital. You're going to tell me 2. In any orbital, there can only be 2 electrons. So what an orbital looks like is they did up here, they do boxes. I do lines instead of boxes just because it's a lot easier for me to draw. I don't really care which way you do it, but I would do, for S, I'd do 1 line. For P, I would do 3 lines. They have 3 boxes. For D, I'd do 5, and for F, I would do 7. So S has 1 orbital that holds 2 electrons. P has 3 orbitals that hold a total of 6 electrons. The D sublevel holds 5 orbitals that hold a total of 10 electrons because each orbital holds 2 electrons. And then F sublevel has 7 orbitals that hold 14 electrons. This is so important for you to remember. Okay, so make sure you get that down. That's really important. There are some rules about filling these orbitals, and the first one you should know is called the off-bow principle. The off-bow principle tells us each electron occupies the lowest energy orbit. So what that means is we're going to start filling, and this is a vertical representation just to kind of get an idea of higher energy levels instead of horizontal like we do it. So basically what happens is electrons are going to fill the lowest energy level first. So first they would fill the 1s orbital. Then they would fill a 2s orbital, then a 2p orbital, and so on and so forth. So each electron, so off-bow principle tells us each electron occupies the lowest energy orbital. Think of it like electrons are lazy. They don't want to climb up if they don't have to. So if you already had 2 electrons in this one, the third electron would have no choice but to go up here. But they really don't want to do that if they don't have to. They're certainly not going to go further than they have to. So all orbitals related to an energy level are of equal energy. So anything that's an energy level 2, we call it equal energy. If it's energy level 3, whether it's 3s, 3p, or 3d, it's equal energy, so on and so forth. Example, the 3p orbitals are the same energy level. All right, the Pauli exclusion principle says that a maximum of 2 electrons may occupy a single orbital, but only if the electrons have opposite spins. So, what's that saying for us? That's saying we have an orbital, and in that orbital, we can only put 2 electrons. The way that we show they have opposite spins is I draw an arrow like that. I only draw half of the top. That's just how most things do it. This one drew both arrows either way. And then the other one goes down, showing that it has opposite spins. Okay? If you have 2 electrons in an orbital, one has to go up, one has to go down. And you can only fit in 2 electrons in an orbital. And I'll show you how this works in a few minutes. If you draw it like this guy right here, with both arrows pointing the same direction, it's going to be incorrect. So you got to make sure you have these opposite spins. So Pauli exclusion principle, opposite spins. They're called spin up and spin down. You really don't have to know that though. All right, Hund's rule tells us that every orbital in a sublevel is singly occupied before any orbital is doubly occupied. So all the electrons in singly occupied orbitals have the same spin. Electrons are unfriendly is the best way to think about this. So if we have nitrogen, and they're showing you in boxes here, what has to happen is that before you can double up in an orbital, you have to have singles in the orbital. So we have 1s, and we can put both electrons in there. Then we have 2s with one orbital. The line is an orbital. Oops. Got ahead of myself. So 1s, we have 2 electrons in that orbital. Then we have 3 p orbitals, because remember, we have to fill off all first, so we have to get them in the lowest space they can. So both of them are going to fill up 1s, then 2s. Now we're in 2p. So we still have 3 electrons to go because we're going to be in 2p3. So we're going to, because nitrogen has a total of 7 electrons, we have 4 right now. So we're going to go 1, 2, 3. They are going to fill in these last orbitals all by themselves before they even think about doubling up, and they all have to be facing the same direction. That's Hund's rule. It's telling us that electrons don't like to hang out with other electrons. A good example of this is it's similar to seats on a bus. On a bus, if you don't know anyone, you're going to go sit in an empty seat before you sit beside some stranger, right? Well, most of us are. So that's the same thing with electrons. They're going to take the empty seat within a sublevel instead of sitting next to a stranger. Okay, so for example, up here, 1s gets filled first, then 2s gets filled. 2p got filled, 3s got filled, 3p got filled, 4s got filled because manganese has 25 electrons. So now we're up to 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. We still have 5 electrons to go. So if you look at 3D, each one of those 5 went into a separate orbital and nobody doubled up. Okay? If you look down here at oxygen, I'm going to draw my lines. So we have 1s, and this is exactly how you're going to do yours. 1s gets filled. We have a total of 8 electrons in oxygen. 2s gets filled. Then we go to 2p. Remember, 2p has 3 orbitals, so I'm going to draw 3 little lines. And I'm going to go 1, 2, 3. So they're single at first and all the same spins. And then if I have more to put in, which I do, I still have 1 more electron to put in because right now I have 7 in there. I'm going to start here and put it beside another one. Okay? So this one will have 2. This one will each have 1. So let's go through some examples together. Let's take magnesium first, I think. All right, so here is magnesium on the periodic table. And magnesium, it's the same as doing an electron configuration, a ground state electron configuration. Really, it's okay if you do the noble gas too. I'm going to do ground state for right now to make it a little easier, and then I'll do one noble gas orbital diagram with you guys. You'll catch on. So we go through 1s2. So I'm going to put 1s here. Remember, S has one orbital, P has two orbitals, D has three, or sorry, I just messed this up. Ignore what I just said. Erase. All right, sorry. All right, S has one orbital, P has three orbitals, D has five orbitals, F has 7 orbitals. All right, so in 1s, we're going to put in 1 electron going each way. Magnesium has a total of 12 electrons, so we got to make sure we get all of those in here. So that's 2. So next we go to 2s. We can put another 2 electrons here. Then we go to 2p, so we need to draw 3 orbitals. And we fill 1, 2, 3. So now we have a total of 7 electrons. We still have 13. So we're going to fill those. That gives us 10. What is it? I'm sorry, 12. That gives us 10 electrons. So we're going to have to go to 3s, 11, 12. So that one's full. That's your orbital diagram for magnesium. It's a little messy, but it'll do the trick. All right, let's do the orbital diagram for vanadium. And vanadium is right here. And vanadium is number 23. So we've got 23 electrons to worry about. Let's do a noble gas on this one because this one's a little bit longer. So the noble gas here is going to be argon. All right, so after argon, I am going to come down to 4s2. So I'm going to draw my line because S has one orbital and put 4s underneath. So I know which energy level we're in and which sublevel. And we fill both of those, 4s2. Then we're going to go to 3d3. Now, D has 5 orbitals. We have to draw them all, even if we don't use them all, okay? So we still have 3 electrons to put in there. So we're going to put 1 here, 1 in the next orbital, and 1 in the next orbital. That means these 2 orbitals stay empty, and these 3 are singles, okay? So that is your orbital diagram for vanadium. It's argon 4s2, 3d3. Hopefully that makes sense. Let's do one more together. Let's do lead. And I'm going to also do a noble gas on this one, which is fine for you guys to do too. So lead is going to be, I'm going to do it above it just to make it easier for me to write on. Xenon. All right, so after xenon, we have 6s2. So 6s has 1 orbital, and we're filling both of those. Now we're going down to F. Remember, F has 7 orbitals. So 1, 2, 3, 4, 5. Get that out of the way. 6, 7. Okay, so I am going to be filling all of those. So we've got 4F14. So remember, I'm going to fill them as singles first to follow Hund's rule. And then I'm going to come back and double them up if I need to, and I definitely need to. Okay, so that sublevel is full. And then I'm going to come back up here to 5D. And remember, D has 5 orbitals. And I'm going to fill all of those. So 1, 2, 3, 4, 5. And yours can just go out in a line if you have space instead of under each other like mine. And then after that, I am moving into 6P. And P has 3 orbitals. And I am going to 6P2. So I'm going to put 1 here and 1 here. That last one remains empty. You guys try neptunium. And I'm going to, if you would pause it while you do that, I'll write out the answer while you're on pause. Okay, you guys should have for neptunium, I did radon as my noble gas. you've got 7s with 2 electrons, and then you've got 5f with 5 electrons, just like that, all the same spin, separate orbitals. All right, so you guys should be in pretty good shape now. You guys now need to do the lecture quiz. If you have your phone available, you can take a picture of the QR code and just take it from there. Or you can go to the link there. You'll have to type it in, or I'll upload. Yeah, I guess you'll really have to type it in. Let me know if you have any problems with it. Okay, so this is going to be on, actually, I'll put this on Canvas for you too, the actual PowerPoint, sorry, so you can always get that link there. So let me know if you guys have any questions. Make sure you get this done before your next class, and I'll see y'all soon. Thanks.